Welcome to Isaiah Shift Part 2, The Evidence. If you watched the first one, that proposed a logical speculation of what could cause such a description of floods, and cyclical was the main thing to remember. So before we go any farther, I propose that we call a galactic year the period between Isaiah shifts, which is approximately 6 to 7 thousand years, which is 6,000 something. So I'm gonna divide it into 6,500. I do not, since this is a random event as we're going through the galaxy. I don't think it depends on our solar years. So it's not gonna be. It's gonna be 6,000 something. So first, I'd like to start with the Piri-Reis maps. This map is dated to 1531 and is believed to have been copied from a different map that dated back 4000 BC, which would be approximately 6,000 years. And it shows, I haven't studied it a whole bunch, but I believe it shows Africa and this Antarctica. This is what an artist description of sonar images of Antarctica if the ice wasn't there. So it's a continent. It has rock and soil underneath it. There's a couple things I'd like to read. First is Lieutenant Colonel Olmeyer, U.S. Air Force, said that the geographical detail shown in the lower part of the map agrees very remarkably with the results of the seismic profile made across the top of the ice cap by the Swedish British Antarctic edition of 1949. This indicates the coastline had been mapped before it was covered by the ice cap. This part of Antarctica is ice-free. The ice cap in this region is now about a mile thick. We have no idea how the data on this map can be reconciled with supposed stated geographical knowledge in 1513. And here's from a different article about the Piri-Reis map. Antarctica today is covered by an ice sheet up to 5 kilometers thick. It is the coldest place on Earth. It is amazingly the driest desert on Earth, with snow only falling around its wind-blasted boundaries. But it was not always so cold and remote. Geologist Molly Miller of Vanderbilt University discovered in the Beardmore Glacier area of the Antarctica the remains of 3 ancient deciduous forests complete with fossils of fallen leaves scattered around the petrified tree stumps. These trees are alive today, but only grow in warm, moist areas such as Queensland. Antarctica also harbors bones of extinct marsupials and dinosaurs with massive coal beds full of once flourishing flora and fauna. All getting a bit complex, but what it means is the ice sheet is not millions of years old, and it also could have been laid down rapidly within a short number of years. This could have happened as recently as 6,000 years ago. So moving down, what else happened, scientists believe, 6,000 years ago? They found, this is a artist, again, like Antarctica. This is an artist's rendition of the sonar images that they found of an ancient city in a half a mile deep water off the coast of Havana, Cuba. And they believe that it traces back to 4000 BC. So again, there's that 6,000 years. They've also found underwater civilizations in Alexandria, Egypt, Bay of Cambay in India. Not sure if I'm saying this right. Yonaguni Jima, Japan, and the North Sea in Europe. So 6,000 years ago, scientists believe all of a sudden this thriving civilization ended up under a half a mile of ocean. Isaiah shift 6,000 years ago would explain that. So we have Piri-Reis map that they believe was 6,000. The ruins off Cabana, and you can look at these other ones, 6,000 years ago. And I've also heard of the same period as Piri-Reis. They had maps of northern Greenland that show it ice-free too, where they map the coast. This is a sonar map of the continent of Greenland under the current glacier. This gorge is 750 kilometers long and 800 meters deep, which is half the depth of the Grand Canyon. So, I don't think a glacier cut that. Moving on. The Yellowstone diatoms. This is incredible when I discovered this, how this little piece of information fit into the puzzle. And just to make it easy, we're going to say diatom B, the one now, is after the glacier melt. Sediment resumes. And the diatoms that they discovered at the bottom of their drill hole is the pre-polar ice cap, the glacier period, the ice age. So they found diatom A at the bottom of the drill hole, and then kind of murky, and then diatom B after that. What's important to note is that they know exactly when the sediment resumed. So let me read from the paper itself. A dramatic morphological shift took place between about 13.7 and 10.0 thousand years ago, but morphology remains stable from 10,000 years ago to the present. We can look in there and find the sediment from 11,298 years ago in the summer, Ed said. The core sample covered the entire geological history of the lake, from its birth 14,000 years ago to the present. Okay, let's take a look at the bottom of the shaft and blow up that section where the ice was. So, the reason I believe an Isaiah shift explains that there was no sediment past 14,000 years to the bottom of the lake, they assume that that's when the lake formed. Okay, let's say it was a lake before that, but an Isaiah shift wiped all the sediment clean, washed it all out. And then a different diatom was present in there before it turned to a polar ice cap. That was an ice age in that particular part of the world, at Yellowstone Lake. All of a sudden it went into, it was frozen. So that's why they found those diatoms there and nothing else before then. Got wiped clean. It was already a lake, but sediment got washed out in an Isaiah shift and got deposited elsewhere. So it was an ice age. So let's go back to their timeline. We know that 11,298, well, that's plus 43 because really the drilling took place in 71, 72. So we can add 43 to whatever that 11.3 is. So 1198, which was, let's go back to the top. Let's say that every 6,500 years, we know Piri Reis, 6,500. The city got underwater in Cuba, 6,500, let's say. So that was one galactic year at 6,500. And then a second galactic year, let's take a detailed look and tell us how Yellowstone diatoms tell us when that happened. Okay, what they think was 14,000 years ago was when the ice started building on the glacier. So you're ramping up, you're building ice fast. And there's no sediment depositing because it's ice. And then it's ice, constant, for at least one galactic year. It's ice age during that period, okay? So, I don't know if it was one, maybe it was two, maybe it was more, but I can tell you that was at least one galactic year in between what they think is 14,000 and what they think is 11,298. So what happened after one or two Isaiah shifts? Two galactic years ago, precisely on the Isaiah shift, it was in a more favorable climate where it is now. Okay, and let's say that the polar cap the glacier melted at the same rate that it formed on the other side. So let's say it takes 1,000 years for that glacier to melt. So, after the glacier melted, this is the murky period in their core samples when it melted and wasn't depositing layers regularly. There was still sediment left behind when the glacier melted, but it didn't start resuming the every year layer on the bottom of the lake until that's when That's 11,298 solar years ago was when the 2 galactic year ago Isaiah shift glacier melted. So we know that here's 2 Isaiah shifts, and here's a third one here because the ice didn't start forming until an Isaiah shift triggered it. So the scale's kind of weird. Isaiah shift is when the glacier starts melting and when the glacier starts forming. Okay? So I believe that we had one 6,500 years ago and 12,500, 13, whatever it was, 6,000 something. And then another one before that. But I really like how this shows us just like the rings on a tree. Alright, sedimentary rocks and fossils. I believe this is the most overwhelming evidence for cyclical Isaiah shifts. I want to read, on the left, I believe this is probably Grand Canyon, the different layers that are laid up there. Sedimentary, all uniform, all different. Different laid down in different periods, over and over and over again. Over here on the right, we have Niagara Falls. This is where Niagara Falls crest was, or Horseshoe Falls, in 1764. And then they mapped it out, different years. This is what it looked like. It's moved 865 feet in 185 years, which is a rate of approximately 4.7 feet per year. That can't have been a waterfall for even millions of years. So let me read real quick. Niagara Falls has moved back 7 miles in 12,500 years and may be the fastest moving waterfalls in the world. And that's from Niagara Park's Geology facts. So again, what do we see there? That's where the coastline was, or no. It's moved 7 miles since the last Isaiah, since the 2 Isaiah shifts ago, 12,500 years ago. So again, there's that multiple of 6,000. So I want to talk about the Grand Canyon now, because that's probably what got the most comments on the first video. And rotate it a little bit more east. There you go. The Grand Canyon, located up here south of the Rockies and north of the, I forget, isn't just going through crossing the continental, the western continental divide. There's a mountain range that goes from the North Pole all the way to the South Pole, all the way. It's a big dam that goes all the way through here, and the Grand Canyon is a hole in that dam that lets water move back and forth. Okay, so that's how I think about it. It got cut through. It relieves water pressure along that whole circumferential divide. Okay, so that's good. Let's look at the geology. All right, what I've done is I've assumed 6,500 years, excuse me, 6,500 years as a galactic year. So we're going to look at the geologic time scale. We have the Paleozoic era, the Mesozoic era, the Cenozoic era, which we're in now. And I counted back, and 65 million years would be 10,000 galactic years. So I kind of put a scale, 10,000, 20,000, 30,000. And it goes back to the Precambrian, which was basically Precambrian down here. This is when we started with no sedimentary rock, only the metamorphic rock. Okay, how do we get sedimentary rock? Well, some places where rock is exposed gets eroded and beat up and broke down, and then something comes along and washes it from where it's at and lays it down somewhere else. So that's why the galactic year is such an important concept. So let's look at the Grand Canyon. Okay, the Grand Canyon. This is just a snapshot. Other places around the world, their sedimentary rock history is going to be different. because this is only applicable here. So let's see how the Grand Canyon formed, okay? We started way back here. Here's the Cambrian. This is schist, and this is granite that's in here that leaves the lines, and I rubber rafted 3 days, 2 nights in the Grand Canyon, and know the difference between taking my schist for granite. Okay, so I've been in this gorge. I've looked at the rocks. I've seen them. I understand it. So what happened all these years? Something every cycle, all the time. Something eroded some of that metamorphic rock and maybe other layers that were down somewhere, and deposited them in the Grand Canyon. Deposit them year after year, same cycle. It brought different rocks from different places, different minerals. Just depending on where the sediment was ground up somewhere else around the world and deposited in a layer. Okay, so sedimentary rocks are evidence of multiple Isaiah shifts, where the forces when we go through there are powerful tidal waves, a Noah's flood type event, where it's the water that moves material from one place and lays it down somewhere else. So what happened to the Grand Canyon between the two mountain ranges? For years and years and years it built up. How many years? Well, okay, this is the Cambrian period. So here's the Cambrian period, was 100 miles long. So here's 80,000 galactic years, 70,000, 60,000, 50,000, 40,000. And if we plot that on the Grand Canyon, we only have, we start with 80,000 Isaiah shifts ago. 70 was the Cambrian, the Mississippian period, the Pennsylvanian period, 50,000, 40,000, and it ends at the Permian period, 30,000. Okay, well, why don't we see these 20, 10, zeros? Why don't we see the rest of them on there? Because that's when the pressure got too big during Isaiah shifts. It was no longer leaving a deposit as something new every time there was an Isaiah shift, or if it switched from ocean back to dry land, back and forth. Because remember, all these fossils were laid down by the different Isaiahs.